Good morning, everyone. As Marek has already indicated, I am joining you from South Africa, and it is really my pleasure to get this invitation. I was really looking forward to be in Warsaw. That would have been my first time visiting Poland, but I guess that this should still happen in future. So I would like to share with you the role of cyber infrastructure in the development here in Africa. So I will take you through some of the things that we are doing and our journey on developing the cyber infrastructure in South Africa. So first of all, just on this slide here is just to give you where we are. Our supercomputer is sitting in Cape Town, and I guess you can see my pointer there. Cape Town is here, that part of South Africa, and this is our building, and you can see the nice views that you can see immediately after the snow ban in traveling. I will recommend that to our center. So we have got what we call a national integrated cyber infrastructure. And initially, we had just the computing, which is the Center for High Performance Computing. And we have also here the broadband connectivity across the country, which is on the SANRAN. And we're also looking at long-term data infrastructure. So basically, for our researchers in the country, we can be able to provide the compute, the connectivity, and also long-term data. Some of the important projects that we're looking at utilizing these facilities is the large-scale science projects like your SKA. We also run a Tier 2 facility for CERN for high-energy physics, mainly for the ALICE and the ATLAS experiment. And we've got big users in bioinformatics. We're also pioneering most of the fourth industrial revolution projects in the country. But more importantly, we're looking at coordinating the efforts of high-performance computing for the researchers in SADC. And I'm not sure here, I wanted to switch on the video, but I don't see it in this case. If you are able to switch it on for me that side, then so that at least I can be able to connect with the audience. So our vision is to make sure that we drive the country for competitiveness. So for that, we enable education, research, and innovation, and we provide shared access to cyber infrastructure facilities. And this is for the whole country. So all the research community in South Africa and the research institutions. So all the universities, we have got 26 research institutions, research universities in South Africa, and all of them use our infrastructure. So, and the mission is to always try and provide world-class infrastructure, which is integrated. But as Marek said in the opening, one of the things that we're looking at is to develop human capital in the country. So training plays an important role in our endeavor. So those are mainly our strategic objectives. As we can see, looking at infrastructure, looking at making sure that we position South Africa hosting of large-scale science projects like the SKA, and we provide human capital development. The other part, as I indicated, we're also looking at the Southern African Development Cooperation. In Europe, I think there you have what we call PRAISE, which is a partnership for advanced computing in Europe. So we have got the similar thing that we want to develop also. regional competencies in high-performance computing. And that is what we call the SADC Cyber Infrastructure Framework, and I will touch a little bit on some of those activities that we do. So on these activities is to make sure that we train people. We have got the meeting with all the member states, and also we have got this report that is reporting to the ministers in SADC, and the ministers participate in these discussions, and they also look at what are some of the things that we should be focusing on. For an example, the need for cyber infrastructure to contribute to data analytics, artificial intelligence, and drive the fourth industrial revolution for SADC is one of the key things that it is being looked at. So I will just go in now in terms of how we put together our infrastructure. As you will see, on the left-hand side, we have got the compute requirements. And on the compute requirements, this will be our high-performance computing with the Scratch, which is mainly the parallel file system. And we have got the long-term data repositories, which we call the data-intensive research. And these have got also their own storage systems. So our design is in such a way that for the users which use HPC systems, they can be able to get that data into this medium term. But in a long term, we are looking also at building an archival system, in this case, that could be a tape. This is still a project that we are still working on. So basically, the users will have access to fast storage, which is linked to our computing systems, and they can be able to store their data into the long-term archiving solutions. And how do we move the data around the country? We have got the NRAM, which is the National Research Backbone. As you can see around the country now, we've got, this is covering all the institutions around the country. And normally we buy capacity from the telcos around here, but also where there is no capacity, we build our own fiber. For an example, if you look at this link here, that is a link that will be taking the data from the SKA site in the Karoo and taking it to Beaufort West, and ultimately it will be coming to Cape Town. So in Cape Town here, we'll be able to collaborate with all other institutions, because you know the square kilometer array is not just a South African project, but we have got other countries that are involved in there. So this will be able to provide that. We also have got the redundancy on the eastern side, which can be able to be used when the fiber on this link here is not working. So basically, we can be able to collaborate with the whole world, and this in preparation to hosting the square kilometer array. Currently, our infrastructure, this is our system, which has been on the top 500 for some time. Now this machine has been over 6 years, over 4 years. It's going towards the 5th year, and in the next years, we will be replacing this system. Mainly, it is CPU based. It is about 1.6 petaflops at the moment. And we also have got the GPU architecture for some of the workloads like your chemistry and material science workloads, but also this architecture it is being used for machine learning. You can see the 3 nodes up here, the highly dense GPUs, 4 GPUs per node, and the 6 nodes down here, these are 3 GPUs per node. And we're using that, mainly the top ones, for machine learning applications. So that creates that environment with variable architectures for our users. And our systems are heavily utilized. You can see on this, mainly our academic institutions, which are universities. We have got the science councils, which are the South Africa public. 5% of this goes also to our South African industries. South African industries, when they use our systems, they also have to pay. So we work on the cost recovery basis, but we also give our capacity also to the African partner countries on the SKA. So this gives you a utilization. It's very important. These are all the universities in South Africa. You can see here University of Pretoria, University of KwaZulu-Natal, Stellenbosch. These are all the universities. So basically, all the 26 universities utilize this system, and that just gives you the percentages on how the systems are utilized. And this gives you, for the different science councils, like the CSIR is the Council for Scientific and Industrial Research, the Agricultural Research Council. So these are the different science councils: South African Space Agencies, the South African Nuclear Engineering Corporation, South African Weather Services. All these are the science councils also that use the facility. And here, these are the different countries that I talked about on the SKA partner countries, like your Ghana, Namibia, Mozambique, and Kenya. So they are able to have access to the HPC systems from their various countries. And some of our industries that use the systems here, this is a mining industry, mining research. This one here, Johnson Matthey, also looking at materials. DBS Marine on mining of diamonds. And then we have got some engineering companies here, but also the bioinformatics companies. So these are the companies that use the systems on cost recovery basis. Our long-term infrastructure plan, obviously, we currently now have got the backbone around the country's 100 giga across the country. We're planning on a long-term 40 petabyte storage. These are the projects that have been implemented from 2019. But with our roadmap from 2021, 2022, we'll be building the 10 petaflop system. And normally our system will take about 6 years. And in between, we do have got also some proof of concept systems that we are building, looking at the different architectures that are coming. Like mainly at the moment, our system is Intel based, but I guess you will agree with me that in the next couple of years, very interesting architectures start to emerge from your AMD and also the different accelerators from Intel, AMD, and NVIDIA. So those will be worth to look at in our new architecture that we will be putting. And we also built an ecosystem. Like in this case, this is where some of our universities don't have the HPC systems. And also on the countries that are on the SKA, there is no computing systems there. So we also have got an innovative way on how we build the skills in those countries. And what we do, we take our HP systems when they retire, and we take single racks, we distribute to those different countries. Through that, we can provide the infrastructure, we can develop skills, and we also start developing research programs in the various countries. Just to touch a little bit on those, you can see here the different countries, like here in Mauritius, Namibia, where we have got different universities that we supported there, Botswana, Zambia, Madagascar, Ghana, Mozambique, and Kenya. And we have provided the infrastructure, but we also do the training for system administrators. We get dedicated staff that are managing this system. So we provide all that training, and from there also provide research activities for them. So some of the countries that are not on our HPC ecosystem, but they have got their own facilities, like Tanzania, Zimbabwe, Eswatini, and Lesotho. So basically the aim is to be able to cover all those universities. As you can see here, this is one of the oldest systems that you might recognize, Ranger, which was based on the Sun system. We worked together with the Texas Advanced Computing. They gave us the system. We repurposed one single rack, and this make a supercomputer for the university in Botswana. They use this for their own training, but at a later stage, they bought also their own supercomputer. But this was very important for them to start the computing infrastructure in their country. Zimbabwe, that's the system in Zimbabwe. They built this, I think it's together with one of the Chinese manufacturers. And currently Zimbabwe have got their own infrastructure now. And we also provide a training. This picture here shows you the participant at the supercomputing conference. And this participant also, they spent some time at a workshop in Texas. And these are the system administrators from different research labs in the continent. So we've got people from Zimbabwe, Mauritius, and these people here were trained to go and start the HPC facilities in their own countries. Again here, not just HPC, we're also looking at a workshop like in Denver in Supercomputing 17, where they were looking at understanding risk in shared cyber ecosystem. So in this case, looking mainly at cyber security. So we try to introduce them not just to the computing, but also how to secure those systems. In terms of the utilization, I'm not going to go deep into each and every one of them, but you can see that our systems here, the use of the systems here in computational mechanics, this is the pyrometallurgy, and this is the design of a DC arc furnace. This is the actual photographic image of the DC arc furnace, and this was simulated. So here we're working together with the researchers at these different institutions to do these computations. Another interesting application here is for the diamond mining. You can see that in the seabed, so you have got the alluvial diamonds that are mined, and using the CFD computations, you are able to do the dewatering subsystem designs. And this is the dewatering subsystem design, and these are the researchers that are working on that. So that's the use of these HPC systems by our industry in South Africa. And again here, this covers a wide range. Like for an example, in here, this was a design of a building in one of the cities in South Africa called Port Elizabeth. And in Port Elizabeth, you've got a lot of wind. So building there, you have to understand your computational fluid dynamics so that you can be able to position the building properly. And this is the work that we are doing. Our approach here is that in some of the institutions, there's no capacity. So we have got our own on-site engineers that did this work. And these are the work that is being done by our different industries here. This is some of the work that is being done by the industry and universities on high-speed trains. And here, this is the work that we have done in the design of the radio astronomy dish to look at the electromagnetic interference in designing the square kilometer array dish. So some of the work, again, looking at South Africa still has got a large number of coal-fired power plants. And this is the work that we have been doing in looking at the nitrogen deposition around the areas in South Africa where there is a lot of power plants. You can see the red there showing you the high intensity of the nitrogen deposition, and you will see that around those are where the power plants are. As you move away from the power plants, you can see the nitrogen deposition here reducing, and then as you go further away in those areas, less nitrogen deposition. So that's a work that is also being done using our supercomputer. Marek talked about our work with the students. And in our students, we take students from all universities around the country. They should be undergraduate students, and we train these students. They spend 1 week with us during our winter, which is June, July. 1 week, we train the students, and after training the students go and design their own supercomputer. They come into the national competition, and from there we select 6 students. The students come from various universities, and these are the students that normally participate in international supercomputing. You can see that since in 2013, our students got the first prize. 2014, they got the first prize again, second place. I would say that the worst position they've been has been a third place, but mainly first 4 times, and then twice second, and only once they came third. And I'm not sure if this year we will be able to have ISC, but it will be good also to continue with that trend. We already have got a team which is ready that has been trained, and if ISC continues, we will be having a team in there. So this has been a very good program, and that builds our skills in the country. And I hope with that, at least it gives you an indication of what we do with cyber infrastructure in South Africa. And I'm happy to receive questions. Thank you.
Thank you, Happy. That was a very, very nice presentation of what you're up to in South Africa. On a personal note, I was in 2013 in Frankfurt at ISC, and I saw your students when they learned that they've won. That was a marvelous sight. They were so enthusiastic, happy. I was really moved. So congratulations for this incredible success with educating students.
Thank you, Mark.
Later during the conference, you'll hear from our students. Of course, we try to learn from you and train our students. They haven't got to that great level, but they are doing fine.
Okay.
Now I would like to open the floor for question or two. The question is, do you cooperate or plan to with East African countries like Ethiopia?
At the moment, there is no active collaboration with Ethiopia, but there has been some discussion with their government, but we plan to work together with all the African countries. Like we do some of the countries I didn't mention here, like your Benin, Cameroon, we work with them. I think the only country close to east of Africa is Kenya at the moment that we are working with. But it will be very good to work with Ethiopia because I understand they are also interested in being part of the square kilometer array.
Well, we'll have a speaker talking about Ethiopian situation in a moment. Before
that's good. I will listen to that one.
Yes, so before we move to the topics of Ethiopian development, I want to ask you a question, Happy. I know that South Africa has share another common thing with Poland, with ICM especially, that we run the same weather model, unified model from Met Office. Could you say something how this model is used for studying, for example, draft and crops and weather change, all those things.
Yeah, I did not specifically put that one because it had an animation, but we do quite a lot with the South African Weather Service. First of all, we're not just providing support for them. They run their own system where they are doing daily forecasting. And then for their long-term forecasting, they use our larger system at CHPC. So we basically have optimized the unified model in different architectures. The other thing that we are doing, we are a failover service for the South African Weather Services, doing the forecasting on the daily forecasting. So the unified model is being used for those short-term forecasting and then the long-term forecasting. We also do some of the packages for the International Protocol on Climate Change, and we use both the unified model and WRF. So we have got a team in South Africa that understand the unified model very well. I think we were the first site to run unified model on the Intel processors. Before that, unified model was just optimized for power processors, which were running on the IBM systems.
Thank you very much, Happy. Great to hear you. Great to have a participant from South Africa.